Hello everyone and welcome back to another Unreal Engine 5 tutorial. Today we'll finish the Forest series with a final polish. We'll add a forest ambience sound, dynamic falling leaves and a dynamic river sound effect. All with minimal performance cost and maximum impact. So let's get started. I'm using two free audio files from freesound.org. Link is in the description. One forest ambience sound and one river sound. To start with something simple, right-click on the ambient sound and create a sound cue. Double-click to open it. Click on the Wave Player node and enable looping. Then click anywhere and enable Override Attenuation. Now we can adjust the inner radius and the fall-off distance. Drag the sound cue into your level and place it roughly in the center of your forest. Depending on the shape of your forest, you can change the attenuation shape. In my case, I'm using a box shape. Switch to Top View and adjust the X and Y extents so they match the outer borders of your forest. Set the fall-off distance to about 2500 and disable spatialization, so it doesn't sound like the forest ambience is coming from a single point. Then switch to the left view and make sure the Z extent covers the full height of your environment. You can also use multiple sound cues to cover more complex forest shapes. Now, when you leave the forest, the sound will slowly fade out and it will smoothly fade back in as you walk towards the trees. The next part is the river sound effect. Right-click on the river sound and create a sound cue. Enable looping and just lower the volume slightly if you are using this sound as well. Enable Override Attenuation. Leave the shape set to sphere, set the inner radius to around 400 and the fall-off distance to about 4000. The idea is to move the river audio along the river spline relative to the player's position. This way we only need a single audio component to cover the entire river with sound effects. To set this up, create a blueprint class actor. Name it BP_forest effects and drag it to your level. Open the event graph of your blueprint, add an audio component and assign the river sound cue in the details panel. Now create two new variables. Name the first one River Spline and set its type to Water Body River. In the Details panel, enable Instance Editable. Name the second variable Character Reference and set its type to BP Third Person Character. Compile and save. Select the blueprint actor in the outliner. In the Details panel, assign your water body river to the newly created River Spline variable. First, we need to initialize our character reference. Go to Event Begin Play. Right-click and search for Get Player Character. Drag the pin out and add a Cast to BP Third Person Character node. Connect Event Begin Play to the input pin of the cast node. From the output pin, add a Set Character Reference node and connect the blue reference pins. Now our reference variable is set to the actual player character. That's our startup setup. To keep the performance cost as low as possible, we don't want to update the audio position every frame. So instead of using event tick, we create a custom event. Name it River Audio. And now call the River Audio event once to start the loop. From here, it will handle updating the audio position automatically. Drag both variables into the graph and choose Get. From the character's reference, add a Get Actor Location node. From the river spline, add a Get Water Spline node. Right-click and search for Find Location closest to World Location. Connect the actor location to the world location input and the water spline to the target input. Set the coordinate space to world. The result is the exact position on the river spline that is closest to the player. That's where we want our river audio to be. Now drag the audio component into the graph. Drag from it and add a Set World Location. Connect the river audio custom event to the input pin of the Set World Location node. Right-click on the output location pin and choose Split Struct Pin. Do the same for the new location pin. And connect X and Y directly. For the Z position, we add a small offset, so the sound comes from above the river and not from the riverbed. Drag from the Z pin, press plus and add an Add node. Set the value to around 200 and connect it to the new Z position. Finally, add a Delay node. Set it to 0.1. Drag the execution pin out and call the river audio event again to create a loop without updating every single frame. Now everything should work. Let's test it. It works perfect, exactly as expected. Finally, we want to create a falling leaves setup. Right-click in the content browser and create a Niagara system. Go to Templates and choose Hanging Particulates as a starting point. Name it Leaves. In the system, deactivate Wind Force, Scale Sprite Size, Scale Color and Sprite Renderer. Then click the plus and add a mesh renderer instead. Here you can assign your leaf meshes. For this tutorial I'm just using one, the one that comes with the megaplant assets we used for the trees. Scale it down a little bit and rotate it 90 degrees. Next, add a gravity fort module. Select the Shape Location module and set the box size to 1000 by 1000 by 1000. Under Initialize Particle, set the min and max lifetime to 10. Reduce the spawn rate to around 15 to start. To test it, simply drag the Niagara leaf system into the viewport. You should see leaves falling now, just to test the setup. Looks great, but if we try to expand the Niagara system across the entire forest, which is far from small, it would be a performance disaster. So instead, we are going to keep the Niagara system permanently positioned in front of the gameplay camera. This way we always see the leaves, no matter where we are in the forest. Open the Effects blueprint again. Add a Niagara component and assign the Leaves Niagara system to it. Create another custom event and name it Falling Leaves. We need the exact camera position and rotation. Add a Get Player Controller node. Then drag the pin out and add a Get Player Camera Manager node. From there, add Get Camera Location and Get Camera Rotation nodes. To create an offset in front of the camera, get the forward vector from the camera rotation. Split the struct pin of the return value, then multiply the X and Y values by the offset distance using two multiply nodes, for example 1000. Next, create a Make Vector node and connect the multiplied X and Y values. Leave the Z at 0 for now. To get the final location for the Niagara system, add this vector to the camera position using an Add node. Finally, add the Set World Location node. Use the Niagara Leaves one. Split the struct pin of the new location input and connect X and Y from the Add node. Connect the Falling Leaves custom event to the input of the set world location to execute the update. To prevent the Niagara system from moving up and down when the camera looks up and down, we use the player's Z position and add a fixed offset. Drag the character reference variable to the graph, choose Get, and add a Get Actor Location node. Split the output pin and drag out the Z output. Add an Add node, set the value to 400 and connect it to the Z input of the Set World Location node. Finally, call the River Audio event. Additionally, change the last node of the River Audio loop to call the Falling Leaves event as well, creating a complete loop for both effects. Hit play and test if everything works. Okay, very nice. The falling leaves always spawn directly in front of the camera. But as you can see, they also spawn in areas where there are no trees around, like our river. So what we want to do is dynamically control the spawn rate of the Niagara system based on the distance to the river. The closer we get to the river, the lower the spawn rate becomes. To do that, we first need to create a user parameter inside the Niagara system. Open the Niagara system and, on the left side, go to User Parameters. Click the plus button, choose Make New, Common, Float, and name it Leaf Spawn Rate. Now click on Spawn Rate and in the Details panel, click the small arrow and search for a leaf spawn rate to bind it. Go back to the effects blueprint, create another custom event and name it Exclude River. Now we need the position of the Niagara system and the location of the river. Drag the Niagara component into the graph and add a Get World Location node. As the river position, we can simply use our audio component, so add another Get World Location node for that as well. Subtract the river location from the Niagara location using a subtract vector node. Then add a vector length node to get the distance between the river and the leaves. Next, add a map range clamped node to map the distance to the leaf spawn rate. Set in range A to 1500 and in range B to 2500. Set out range A to 0 and out range B to 15. This means if the distance between the Niagara system and the river is between 1500 and 2500, the spawn rate will smoothly change between 0 and 15. Now, right-click and search for Set Float Parameter. Use the Niagara Leaves one again. Connect the output of the Map Range node to the parameter value pin and connect the Exclude River custom event to the input pin. As the variable name, choose the exact name of your user parameter for the Niagara system. In my case, Leaf Spawn Rate. Now, just call the River Audio event and change the last node of the Falling Leaves chain to call Exclude River. So all three effects are now running in a single loop. Hit play and watch your forest come to life. And that's it for today. Thanks for watching. I hope you liked it and it was helpful. If you want more tutorials like this, just leave a comment. Cheers!